All right, so 2.1, rates of change and limits. Okay, rates of change is going to end up sounding a lot like physics here in just a second.
Physics. I need special help in physics.
Y equals f of t is the average speed during an interval of time, and that's going to be distance divided by time. Average rate of change also known as average speed is f of t plus h minus f of t all over h equal to delta y over delta t. Instantaneous speed is the speed of a moving object at a given instant of time. All right, this next thing I'm going to write is going to look really big and scary, but I promise it's not. And it's something that's very important that you know what it is. You could over there?
No, I can't spell. I don't know why H's look like these.
All right, definition of a limit.
Gonna be nothing but the ball of motion. I have a fork in my backpack.
Congratulations. Assume f is defined in a neighborhood of C, and let C and L be real numbers. The function f has limit L as x approaches C if given any positive number epsilon epsilon.
Oh.
What'd you say?
Epsilon.
Where is that on that?
Huh? The E is epsilon.
What does that mean?
It's a positive number.
Why are we making music?
It just is.
So,
It's the definition of a limit. There is a positive number delta such that for all x, 0 is less than the absolute value of x minus c is less than delta, implies f of x minus L is less than epsilon. So we write a much simpler version. The limit as x approaches c of f of x is equal to L. There's a nice long proof in college that I had to learn, but I'm not going to make y'all learn it. Properties of limits.
What is that weird looking S?
This?
Yes.
Delta.
What?
Delta. The half 8.
I thought delta was a triangle.
It's another way to write it.
Why?
Are you sure it's not an earring?
Huh?
So are you sure it's not an earring?
What does upside down A mean?
For all.
That's like an F with a flash.
Relate the meaning to always.
All right, this first property is the limit as x approaches c of k just being a number, is equal to k, because the limit of a function with constant value k in this particular case you good? And the limit as x approaches c of x is equal to c, which is the limit of the identity function
I just wrote re-white.
at x is equal to c.
I don't know how to spell equations. I spell I haven't read it.
How do you know it's about precious?
How do you, that's how you spell approaches?
Precious.
No, I spell APPROCHAS.
Roach. It's like a roach. Approach.
Oh, I'm still gonna write that.
You know what? I almost wish you fucked all the other girls.
So what?
Yes, I
You
wish
just have to be a whole nother level of stupid and not find the values.
Yeah,
Well, and again, I don't know what the Latin math looked like.
I don't know. Maybe I'm gonna give you all of the literally every single possible hint mankind.
I was just calling to find me. I think she was looking out for the table and
K or X?
I was just
K.
a friendly NPC.
This one is a k. This one is an x.
I tried to start a bar fight. But nobody knows that it's not a bar fight.
Who's your name? So I can knock some of the scrap of that project.
Half holiness. Search.
Oh, no, I wrote that.
I like freaked out. I had no idea. I was like, I don't know.
How far up can I go?
Oh, I'm at the curly V.
The curly v.
Oh,
Yeah,
it's upside
curly
down
V.
A.
No, it's the curly V.
Okay, for all x. Whee. Okay. Alright, then we're gonna have a theorem. If L, M, C, and K,
That's the delta sign, right?
yeah,
How much space do I need for this?
for the theorems,
Yes. Like a lot.
there are,
Like more than 5 lines.
yes, much more than 5 lines. There are 6 of them.
Smiley face. Yeah.
They're real numbers, and the limit as x approaches c of f of x is equal to L, and the limit as x approaches c of g of x is equal to m, then we have the first one is the sum rule. Says that the limit as x approaches c of f of x plus g of x is equal to L plus m. The difference rule says that the limit as x approaches c of f of x minus g of x is equal to L minus m. How far down are we?
Constant value K. Okay, just one.
Product rule.
Oh, it's
The
a difference
limit.
rule, not different rule.
As x approaches c of f of x times g of x is equal to L times m. Constant multiple rule. The limit as x approaches c of k times f of x is equal to k times L. Five, the quotient rule. The limit as x approaches c of f of x over g of x is equal to L over m for m not equal to 0. And 6, the power rule. If r and s are integers, s not equal to 0, then the limit as x approaches c of f of x raised to the r over s is equal to L raised to the r over s, provided L to the r over s is a real number. How far up can I go?
I'm at product rule.
Beautiful. Alright. Theorem 2. This is the polynomial and rational functions. Alright, this one is also in 2 parts.
Do I need like over half a page for this if I skip lines between?
I mean, I wrote really big and got it in half. It's what's in red. So I think you're fine. If f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 0 is any polynomial function and C is any real number, then the limit as x approaches C of f of x is equal to f of C is equal to a sub n, c to the n plus a sub n minus 1, c to the n minus 1 plus dot 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 a sub 0. Next one, if f of x and g of x are polynomials and c is any real number, then the limit as x approaches c of f of x over g of x is equal to f of c over g of c, provided g of c is not equal to 0.
Is it, so in the first limit, f of x equal to f of c, is that equal or minus?
Equal. Ah, well now it's a minus. There we go.
Is there any more of this particular section?
Nope. Next thing is 1 and 2-sided limits. Which for me was 1, 2, 3, 6, 11 lines. A sub 0, yeah. Alright, 1 and 2-sided limits. Sometimes the function will go towards different limits.
A little bit.
Huh?
You're off just a little bit.
As x approaches c from different sides. So the right-hand limit the limit of f as x approaches c from the right and that would be written the limit as x approaches c with a little positive sign, okay, and that little exponent of f of x is equal to, and then we'd fill it in. The left-hand limit is the limit of f as x approaches c from the left and that looks like the limit as x approaches c, and in the exponent it's just going to be a little negative sign. It's not actually an exponent, I'm just describing it that way. But f of x is equal to, are we all down to the 1 and 2-sided limits?
I'm writing the last thing
Okay. Go like there, we're good. And then the last one is the 2-sided limit, which is what you've been seeing, that we've written all up here up until this point, okay, where we wrote the right and left hand ones. So that is the limit as x approaches c of f of x is equal to, and then whatever it would be equal to in that particular case. And then we're just gonna, well, we're not just gonna do, we're gonna do 2 more theorems. And then we'll go from there and see where we're at. Theorem 3 a function f of x has a limit as x approaches c if and only if the right hand and left hand limits at C exist and are equal. Okay, so this is true forward and backwards. I'll show you in symbols what it looks like in a second. So this would be something like the limit as x approaches C of f of x is equal to L if and only if, okay, remember that's what the two-sided arrow looks like, or what that is for.
Oh, the plus and the minus signs are superscripts?
Yeah.
Okay.
So if and only if the limit as x approaches C from the right of f of x is equal to L and the limit as x approaches C from the left of f of x is equal to L. And the next theorem might make you a little hungry. What?
I'm already hungry.
Me too. TBH. All right, and then the final theorem, it's actually a named theorem. It is the Sandwich Theorem. And it says that if g of x is less than f of x is less than or equal to, or sorry, they're both less than or equal to h of x for all x not equal to c in some interval about C and let's see. The limit as x approaches C of g of x is equal to the limit as x approaches C of h of x is equal to L, then the limit as x approaches C of f of x is equal to L.